Good morning. Hello everyone. I hope all of you have completed Inferential Statistics. But this video is not to do Inferential Statistics in such a manner that you are the beginner of it. This is just a revision class, and what exactly you want to revise, you have to revise, that you need to know it. Because you had many questions in the class. You have asked your teachers that age estimation is there. Age t-distribution to sample test is there. What is the concept of pooled standard deviation when we are doing inferential statistics? All these questions I will answer one by one before we start the main topic. Let us know what you need to study. I will do this for very first, promise with you that this data I have collected from that CBSE website, population and sample. What is the learning outcome over there and explanation for it. If you go through it once, you will see that this topic is just on population and sample and representative sample, how to draw. Representative sample only we take, not non-representative sample, systematic random sampling. We follow this only, systematic random sampling. Because otherwise some problem will arise. We cannot favor any particular event to take into our consideration. We cannot have choice. We have to make every selection mathematically. I am coming back to that point. Then the next topic is parameter statistics and statistical inferences. So in this article I will explain obviously what is parameter, what is statistic and what is statistical inference. Next there is t-test, one sample t-test and two independent group t-test. This is included in your syllabus. You will come to know how null and alternative hypotheses can be formed, can be made, and how t-distribution table will help you to get those values, those critical values of t quickly and properly. That also I will explain. So without wasting our time, let us start inferential statistics once more with specific aim that what exactly you have to revise in it, because it carries 5 marks and 5 marks you have to secure over there. So what is inferential statistics? There is a part of statistics which you have already studied in class 11 syllabus. Why this one again? Is it the same thing which we have done before? Is the mean, median, mode, all these have the same importance? My answer is they have importance, but we are going to study something different. This is the time to make inferences, to draw conclusion about a big data. So today we are going to talk about big data, not in the sense of computer science obviously, but still the concept lies there also. So this is big data analysis. We will do with the help of what? Mean, median, mode only. But as a whole, we cannot do it. Descriptive statistics, what we have done in class 11 or before also, that it provides a summary of data, helping to present and understand the main features of a data set. For an inferential statistic, it enables predictions or inferences about a population based on sample data, allowing for broader conclusions. So, what is population and sample? This you need to know first. This you need to remember first. Population means like huge data. Set up all the students of your school. This is population. And set of students in your class. This is statistic. So, how the quality of the school, if you want to judge or someone want to judge it, he cannot do it for each and every student of your school. What he will do? He will select a class. He may select all the first boys, then mediocre boys, and those who are backbenchers. He can select student of your class only, that one class 12 student of this school, class 12, all the class 12 students can be a sample for the population, where population is the total number of students of your school. If you want to state something about habits of Indians, population of India is huge. So what you can do there? You can do this way. State-wise you collect 10 data, 10 people. Ask them about their lifestyle, everything, what you want to know. This way, out of 140 crore people, you might have taken 280 or 300 or 350 only, and trying to say something about the habits of the whole population of India. This we don't do in descriptive statistics. We have never done, we have never drawn any conclusion in descriptive statistics. We have just stated it is the mean, it is the mode, it is the median, and not for large data. Data was not very large. We are able to calculate, we are able to state about mean, median, mode of the data set, which includes few number of members only. But where crores of people are there, to state something about them, you need to select sample. Something related to sample will be referred as statistic, and something related to population is said to be a parameter. Here in this diagram, I have tried to explain the meaning of population and sample. Many families are there. You have selected this family only. These are the families in a village, say. Then this family is going to be the statistic. All the people in the village will make the population. People from here only, from one family only, will make the sample. Okay? So population encompasses the entire group being studied. This includes all individuals or items of interest. Sample is smaller subset of population used for analysis. If I go by the set of, whole population as one set, this is the set. Okay? This we can state as population. a smaller part of it or a subset of it can be considered as the sample. Okay, sample may be like this. This is sample and this part is population. So smaller part of population will be a sample. Now there is another term that is called sampling. So population, sample and sampling. What is that? Population, sample and sample you have understood. That sampling means obviously method of selection of the sample is important over there. But what sampling will do? Sampling as a whole will draw conclusion. This is a method actually. Conclusion about the population by studying the sample. So if you see that sample mean as X bar, population mean as mu. Just a minute. Just let me move it there to the side. Yeah. That sample mean is X bar, population mean is mu. If you take sample variance as A square, then population variance will be taken as sigma square. Okay? Sample standard deviation, if you take S, sample variance will be taken as sigma. Okay? So what we have done there, that in case of sample, we are using small letters like X bar, A square and S to represent mean, variance and standard deviation. Okay? And for population, we have used the symbols mu, sigma square and sigma to understand population mean, population variance and sample this is not sample, by mistake I have written population variance. So the second row for population, first row for statistic. So from any set, this is a question the board asked, from a set like the population with this A1, A2, AN, this way it continues up to infinity. All members are taken this manner. Question, can this be a statistic or population? We have taken up to 10 only. Out of infinite number of elements, it's huge. That's why we are not able to express in terms of number. From there we have taken 10. So this will be a statistic. And we have taken this sample from the population. Now this sample to be analyzed, to predict, to draw conclusion about the population. So, in our calculation, after sampling process done, mu is going to be x bar a square sigma square and A is equal to sigma. So if your process of selection is perfect, then you have stated correctly about the population. By calculating sample mean, sample variance, sample SD, you have stated about population mean, population variance, population standard deviation. Extremely sorry. This is population SD. This method is called estimation. Okay? We are estimating about population, this quantities, by knowing all those three quantities at sample. I mean mean, median, mode, standard deviation, quartile deviation, percentile, whatever you find here for sample, that will be true for population. And if you have drawn a proper data set for sampling, then your result will be correct and there will be no error. But estimation will be incorrect if you have selected sample wrongly. This you have to keep in your mind. So you have to apply proper mathematical or statistical method, whatever you say, properly. That sampling to be done properly because you will use technology, but sample selection, how many will be there in the group, what are the points to be included over there, and which method you are going to apply. Unfortunately or fortunately, this estimation theory is not in your syllabus. So even you will not be prepared for mean estimation, standard deviation, variance estimation for the population. Okay. So now this method, that theory of estimation, is not included in the syllabus, and we are not going to do it also. This is one thing. Remember, you might have trained this manner, that estimation is there, point in estimation, interval estimation, all those things you can avoid if you know the syllabus. That's why I have shared with the document and syllabus is given over there. Please go through this. Now, before we do any numerical calculation, just see what is left in theory. That population I have explained, sample also I have explained, subset of population this way. Now that sampling when you are doing, some data may not represent the element of the population. Okay? This will be referred as non-representative element in the sample. The whole sample will become non-representative. So what is a representative sample? This I have explained here. Sample that accurately reflect the characteristic of the population as a whole. That is definition of representative sample. Like suppose in one survey, I have taken this example here, 50% of the population is female. A representative sample will have around 50% females. Okay? So what to do? Will you say that it is representative 50% population female and representative sample you have taken 50% female only. So this is of course representative. Remaining 40% was present and 40% going to be added next year. Okay. So this is the meaning of representative and not. Don't waste much time here, because if you know the term, you can define it yourself. No problem. Okay. Now, see, in this sample, so many are there, out of which this one marked red. Why? It is marked red because it is not looking like other person. So it is different. This should not come into the sampling. That's why you change your position. Even you might go out, because those 15 are to be selected. Is that clear? So how to draw a representative sample? This I am going to tell you. I have promised with you that whatever there in CBSE syllabus, I am going to do exactly that. Nothing more, nothing less. So representative sample, non-representative sample is there. You have to know. That's why. Now, how to draw a representative sample? A representative sample, my drawing can be done by this famous method, which is called simple random sampling. Each member has equal chance of being selected. Okay? So, random generator, number generator, or names from hat can help you. Okay? So you do it later, but know the process now. In simple random sampling, each member has an equal chance of being selected. Systematic random sampling, here every kth member of the population, sometimes you say third, sometimes 5, select every kth member of the population. Method, choose a starting point at random and then select every kth individual. Like you are taking 5th, every 5th from the group, you have taken 5th, then 10th, this way. So systematic random sampling method, you have to follow always that every kth member of the population, when you have selected, there is no choice from your side. You have taken every kth member of the population. Fine. Choose a starting point at random and then select every kth individual. So this is not the case for board exam. In your study material, which is well defined, that only can be asked. I am not talking about solved examples. You have solved example books, many of you. Actually not required. Okay, so this is simple random sample. Now, you have studied simple random sampling, systematic random sampling. Now, population data. Where you get? What is a population data first? Tell. What is a population data? You must try to say. Population data means which you are selecting from population. Gather data from sources like census, economic survey, and that voting result. How do they predict? All the websites are behind it. They have taken from here. It may be done by someone that you can draw from there. Okay? So, census data for determining population of the country, economic surveys for the business. Okay? Now let me tell you one example of sampling. Drawing more than one sample set from the same population to compare the result. We are taking one sample from here, one sample from the other, that's whole room is population. And then we are calculating their difference. That is also sampling example. And unbiased and biased sampling, unbiased means you are not preferring any person who is not in the queue. Suppose you are sitting there in Apollo Hospital counter and you are taking only unbiased sampling technique. Biased one, step by step he is supposed to come. He is giving A, that, just a minute. Drawing more than one sample from the set of same population to compare result, representative, non-representative, biased and unbiased. Sampling technique. So, suppose you want to draw 10 students from a class of 100 by using simple random sampling. What is the simple random sampling? Each member of the population has an equal chance of being selected. So, here you cannot use the table you have got previously from CBSE. Here you have to explain the technique. Okay? So this kind of problem they are asking, that systematic random sampling, how it is possible, where the problem is to select 10 students from a class of 100. You just think how you select. Sample of 10 students from a class of 100. How do you select? Is there any choice? You have to select 10 out of 100. Suppose you said that I have selected the 5th student. So 5th, 10, 15, this way sampling can be done. Okay, you are selecting every 5th student from the class. Roll number 5 you take, roll number 10 you take, 15 you take, 20, no, 20 you take, this way. But if you don't have time, you cannot perform the experiment, then you have to take the help of someone, from someone. Isn't it? But this is very interesting. Only because of that systematic random sampling you are doing, and this method will follow. You are selecting 5th person, every 5th person means your data finding will be over after 50 observations. But ours will be continued till 100. Okay? Then parameter, already I told you, whatever related to that parameter of the experiment, that is called population mean, that mu we take, population standard deviation, sigma we take. This I told you earlier also. What is statistic? This is a measurable characteristic of a sample. Okay? Measurable characteristic of a sample for statistic, and previous one for parameter, this one for parameter. It is completed over there. Then we are going to do statistic. A measurable characteristic of a sample is called statistic. Sample mean x bar, sample standard deviation S. Okay? Sample mean we denote by x bar. Just a minute. And sample standard deviation is S. So you have learned these two terms. One is parameter and one is statistic. Parameter related to population, statistic related to the smaller part of the population which you have taken for analytical study of the population. Okay? Then limitations of sampling in statistics. Just the way I told you, just decide whether on that you can discuss this part or not. What are the limitations of sampling in statistics? The limitation is that sample statistic may not perfectly represent the population parameter. And number two, sampling error and bias sampling error and bias can affect the accuracy of statistics. Suppose you are not following any special technique. You are selecting one from here, second from there, third from there, then fifth from there. For sixth one come back, then again go this. This is random sampling. We will never do it. We will follow procedure. We select first boy. For 10 selection, so for 5th selection, that is also boy. 10th one, 11th one, 10th one, 15th one, 20th one. 5 boys are done. But class you cannot predict if you have taken roll number 1 and then roll number 40 with it. Okay, here specific method you have to follow. Either you take that every kth element from the set of comes, camel say, you are selecting every 10, then this is systematic and this is correct. But this may be wrong also by the wrong choice of statistics. Be careful of it. Okay? So this is the main limitation of sampling in statistics. What is statistical significance? Try to remember it. All of you have done going for board exam just after a few days. What is statistical significance? A result is statistically significant if it is unlikely to have occurred by chance. In other words, there is enough evidence to believe that effects are different in real and non due to random variable. Okay? Now concept is what? You should remind object effect in sample exists in the population. You understand what I told? First is the definition. It is statistically significant if it unlikely to have occurred by chance. There is no chance, but it has occurred. There is enough evidence to believe that effect or difference is real and not due to random. So concept, you should remind the object effect in sample exists in population. Method will follow that only. You take every 5th student, every 10th student, that's okay, no problem. Okay? Now what is statistical significance? This is used to determine if the object effect in sample exists in population. This is significant. Statistically, I have written two definitions over there. It is significant if it is unlikely to have occurred by chance. By chance. Okay? In other words, there is enough evidence to believe that effect or difference is real and not due to random variation. Okay? So, when you are going to check whether statistically significant or not, then there will be evidences to believe that the effect of difference is real and not contestable. Then, central limit theorem. What is that? Central limit theorem. Anybody knows? What is central limit theorem? This you need to know. Can you find by the method I told you, by learning formula also, can you find everything about the population? Is it possible? Just by knowing that sample mean, sample variance and sample standard deviation, we are telling that this mean, variance and standard deviation will be true for the population from where it is taken. Then what will be your answer? My answer is going to be that, just a minute, it moved. That for a big data, we cannot use this sampling technique. At this moment, we'll forget about very big data. Okay? Very big data will not take into consideration. Then central limit theorem says that when data are very big, then sample mean will be approximately normally distributed regardless of population distribution. Okay? It will be normal distribution then. All formula going to be different over there. Okay? That statistic, everything, little bit idea over there, you have it. But here I am telling you, for that, if you want to do it in this chapter only, then you have to use Z-test. But Z-test is not in syllabus. Z-test is not in syllabus, so we will not do it. Okay? So, small sample test, what to do? If you are testing a sample, for testing a sample, what to do? Large sample test, not required. This one, this is small sample test. Small sample test, how you do? This will do by the use of t-test or students t-test. This is another name, t-test or students t-test. It was discovered by William Gossett. Okay, the year I don't remember. But this t-distribution, testing the sample by using t-distribution is the most important topic. Why? Because basically we draw conclusion over there by knowing this thing and another topic that is called degrees of freedom. Okay? That we'll do later, but before that, let me tell you, this small subset we are doing it by t-test. T-test also two types. One sample t-test, this is basically for n less than 30. Okay? Z test what we have done, large sample test. This is large data, but n greater than or equal to 30 means you have to stop working. So one sample t-test will do if one sample t-test will do if n greater than 0 less than 30. We can do two sample t-test also. Two sample t-test, I gave you some elementary idea about it. Two sample t-test is also there. I mean, suppose from a population you are testing two statistics, whether their means differ or not. Or suppose when you are going to draw a conclusion that about some event you have written that my assumption is this is not true. Okay? Or my assumption is the amount of your salary is not equal to 50,000. What will be the alternate one? Alternative hypothesis. This will be taken as XII. XII means what? You will assume that it will be true. If you want to find the population mean with the help of sample mean, then you will say that sample mean x bar is always equal to this mean bar. This is hypothesis. This is called null hypothesis. For the alternate hypothesis regarding sample, you are telling that no, x bar not equal to mu bar. Then this is called alternative hypothesis. Okay? We will learn one by one, step by step, how to apply one sample t-test, how to apply two sample t-test in these two different cases. Okay? So one sample or two sample, no, not one sample, two sample. The test may be right-handed test, may be left-handed test, or both-sided test. But those all will be doing with the help of pre-distribution table. You must see the table one. Must go through the t-distribution table once. T-distribution curve, you remember, you have done it in probability. That t-distribution curve, do you remember? Don't remember. It's something like this. Okay? So here data, I told you it will be less than 30. Most ideal case less than or equal to, up to equal to you will consider. The area will represent probability. Suppose a coordinate Z1 is here, Z2 is there. Z2 negative, obviously you can take minus Z2. What is the chance that Z will lie between Z1 and Z2? That we want to check. What you have to do there? There you have to assume the null hypothesis. And then you go for statistical analysis. Then finally you will draw the conclusion by calculating the tabulated value and the calculation you did. What calculation you did? Is the graph enough? T-distribution curve enough? No, it is not enough, because numerical calculation will tell you what you have done in your copy. If it is not matching with the table value, then there will be error. So I have to give you the concept of error. Although error analysis we are not going to do, that how error can be made, that I am going to tell you. How error can be made. Then we will proceed this again. There is a class of 39 students. 2 students are there Devans and Bonalika. Bonalika and Devans. And there is a teacher whose name is Mr. Sarkar. Okay? What error can be there, that I am going to tell you. What error? Suppose in this class of 39 students, your teacher, Mr. Sarkar, had asked you to find that by the method of sampling you have learned, can you tell me the class average in my subject, applied mathematics? So what the teacher has done, he has chosen 2, that Devans and Bonalika. Then Devans and Bonalika, as they have learned statistical analysis little bit, they will say that yes, we can do it with the help of hypothesis, with the help of that sampling I would like to do. Out of 39 students, Devans has taken the marks in applied mathematics for 5 students. 52, 54, and the other one is 40. This is, say, 5-3, and next one 4-3. Okay? And Bonalika has collected marks of these remaining some other 5 students from the class, not Devans, maybe 1 or 2 common, it doesn't matter. She has collected this data: 60, 80, 72, then 63 and 65. Bonalika has collected this sample, their marks. She has friends, 5 friends. She has taken their data. And Devans is very smart. He can take it the way he likes. But if sampling is dishonest, he has not followed whatever we did here, then that calculation may be wrong. Okay? And Mr. Sarkar on his own had seen that class average is 74. Class average is 74. Now tell me, who is correct? Bonalika, that Devans, Mr. Ravi, or all three of them. Now, what we'll do here, we will find the average here. Average, his teacher already calculated 74. That's this problem given to you as your statement. Just a minute. Two 242, and here 5, 6, 10, sorry, there's 0, 10, 1, 13, 20, 28, 34. Okay? So, what is the average calculated by Devan? That average will take small x1 that is 5 4s are 20, 42. Just a minute, sorry. 49. And here x2 bar will be what? 340 by 5, 68. See the difference now. With this population, Devansh had estimated his marks far deviated from 74. This is an error in your calculation. So error, if you write, error made by this boy will be 74 minus 39. So 74 minus 49. 25. This error we are taking as E1. Second error between this and this will be what? That's 69 minus, 74 minus 68. So, this error is different. This error is different. If we want to compare their means, the mean they have got, whether significant or not, whether this mean should be rejected or not, we need to use the similar analysis for the way you do for standard deviation, variance, etc. Okay? So there is, in our calculation, there is error. Error made by Devansh used 74 minus 13, that is 25, and by Bonalika it is 74 minus 68, that is 6. Okay? Now we are going for hypothesis testing. What is that? Hypothesis testing. In hypothesis testing, you will first do the sampling. Step 1 will be do the sampling. Step 2 will be what? You find the sample mean, variance, whatever required. Okay? Because you are going to predict about population. I got mean over there at x bar. Can I say that x bar equal to mu? we can or we can't. So when you say that x bar equal to mu, then that will be null hypothesis. Where we don't find any point of rejecting the statement that x bar not equal to mu. So that's why this will be considered as the null hypothesis H0. Okay? And for this one, that will be considered as HA, the alternative hypothesis. This I told you earlier. For that, there may be x bar less than mu, x bar greater than mu, x bar may be greater than mu, that x bar not equal to mu. So when hypothesis is x bar equal to mu is the null hypothesis, this is alternative hypothesis, and three different ways we will decide whether this mu equal to x bar or not. For this one, we go for left tailed t-test. For this one, we do right tailed t-test, and for this one, we will be doing both sided t-test. Okay? Now to understand that left-sided, right-sided and both-sided, we have to take the help of the t-distribution table and that curve, corresponding curve. Okay? For that, we need to know two more things, that is degrees of freedom. This you need to know. Degrees of freedom. What is that? Degrees of freedom for n number of observation, for number of observations equal to n, DOF will be n minus 1. What is that? What does degrees of freedom actually represent? Degrees of freedom actually represent the number of possible options of the sampling. It means what? What do you mean by that? Suppose in your class 39 students are there. Out of these 39 students, when you are entering the class, then suppose you are the last person. First one had seated over there. For him, how many choices were there? All 39 choices, 39 benches are there, 39 chairs are there. Okay? "39 options are there. For the second one, 38 options are there. You are in the queue. For third one, 37 options are there. For fourth one, 36 options are there. It's like this. But for you, you are the last one. You don't have any option. The 39th seat you have to occupy. So before you, those 38 people, they have choices. You don't have any choice. So number of people, they have choices in the sample will be referred as degrees of freedom. So degrees of freedom will be 39 minus 138. If the sample contains n, then degrees of freedom will be n minus 1. Clear? Now, if there are two groups, say one group contain n1, one statistic contain number of observations in one statistic, the second statistic contain number of observation in 2, then the group of n1 plus n2, how many will be there? In this group, number of DOF, this will be equal to n1 plus n2, that is n1 minus 1 plus n2 minus 1. So it is n1 plus n2 minus 2. Okay? Now, you have to understand this sampling method. I have tried to tell you that population is there. From their sample you have taken, data collected, data analysis. Now you are in a position to draw conclusion, to make statistical inferences over there. For that, I told you, concept of two things are required. What are those? Degrees of freedom, that we have understood, that number of choices in a group to perform a task, similar task, and then the t-distribution table and the corresponding curve. That we are going to discuss now. This curve we will be discussing now. Okay? What to do with this curve? This is called t-distribution table. Okay? Now, when you are going to do statistical analysis, you need to get the value of t from that particular statistic. That t is done by this x bar minus mu, that divided by s by root n. Okay? This t value you have to calculate when you are going to compare the sample mean with the population mean. Same thing applicable when you are going to consider two means. The concept of two means I have explained. I'll do it again. But before that, this t value you have to calculate from the graph like this. Okay? You need to see whether this t value lying on the left part of the graph or on the right part. Okay? Left part means towards origin, right part means, leftward of origin, and this is rightward of origin. So critical t value, if it lies on left part of origin, it will be negative. Corresponding region you have to draw there. If it is positive t value, then it will lie on the right side of this curve, right side of the origin, and this t value will be positive. So this will do for what? This will do for left tail test. Left tail test when little bit idea I have told you. Left-tailed test means when this part negative, x bar less than mu, t is becoming negative. So we need left tail test. If x bar greater than mu, then this implies t is positive. For that we need right tail test. And if both sided test there, I mean when you are going to decide about this thing, x bar not equal to mu, you need to test left hand, right hand, both. Okay? Critical t value, x bar not equal to mu means it may be positive, may be negative. It will lie on both sides. You need to check that. Okay? For that, we need to use both sided t test. Now, what this value will give you? This t will give you, this will give you the critical value of t. Okay? So, this is 0. When you have taken x bar equal to mu, this is null hypothesis. HA, when you have taken x bar not equal to mu, this is called alternative hypothesis. When you are doing all these things, you need to check whether the value of this statistic, I mean critical value of t, is falling in the shaded region or outside it. If it falls in the shaded region, then you have to cancel the null hypothesis. If it doesn't fall, then you have to accept that there is no reason of cancelling the null hypothesis, rejecting the null hypothesis. Got my point? So these are all steps. X bar where have you got? X bar you got from sample. Sample where have you got? From population. So population to sample. Then sample variable x bar, mean, right now at your level mean only, not standard deviation or other things. That you are going to compare with the population. Because your main aim is the sampling. Sampling means you state something about the population with the sample data you have taken. So for that, all those steps should be clear first. Then go for next step, calculation of t, x bar minus mu. There's some stated value of mu there. Population mean is 5. But you are getting is 4.9. This distribution table and this curve will tell you whether this can be accepted or not. And remember, for every order given by the company, huge order, this test is essential. Okay? It's a part of statistical quality control. Okay? So let us take example, because I wanted to make the session brief so that whole of inferential statistics you understand easily. But till I am continuing, it means we have nothing to do. Okay? So we are going to solve the problem 1 based on this. Another thing, just before doing that, one sample t-test I am revising here. It's very easy, believe me. Once you know the meaning of population, statistic, sampling, the process of sampling, then you have won the game. That's why when I was doing that, I was feeling sleepy because you all might have done it already. But this thing is very interesting. Numerical calculation is there, table is there. Be ready with your pen and pencil to do it with me, pen and paper to do it with me. So statistic will be taking, t-value will be taking using this formula. It is x bar minus mu s by root n. N is the sample size, s by root n. For sample, everything root n. Although I need not discuss because I am strictly according to the syllabus given in your board paper. So that you study today, you do everything with me and then go for exam straight by remembering just common thing, this one and this one. There is no chance of asking question from, where variances are different. Right now we are not going to do. Okay, normally they ask on this. So let us focus on it first. If this one comes in our example, we will definitely do. But put stress on this, understand this, then everything is done. Okay? Here, this we need for comparing two means. Two means so far they have not asked. But you need to prepare, be prepared. So steps I have told you, I am not going to tell you again. What you need then for analysis? You need the table, this table. So I am copying the table here. Making it a bit short so that comparison will be easier. Yeah, let us calculate, not so big, again there will be problem, there may be problem. You can't see the data, then purpose will not be solved. We will be able to see it. Let us pay attention in the sum now. 5 marks given. Maybe all those they have asked 1 or 2 mark questions before. Least chance is there. But you need to understand this table, believe me. I go back there again. The statistic. I go back there again to explain this term that is called significant level and confidence level. Statistical analysis, no? Your difference may be significant, then you will cancel. This is called significant level. Okay? Confidence level, then you are going to accept. Okay? If you have taken that, if you are saying something like this, I have to explain it to you a little bit, otherwise you cannot start that. Suppose we are 95% confident that my calculation is correct. Okay? I am 95% confident that my calculation is correct. Where have you seen this kind of thing? Let me go for this example which we have already taken. This thing. Class of 39 students, Devans and Bunalka, has done some calculation. There is a maths teacher, Mr. Sarkar. His calculation is like this. Now you have some special parameters. With the help of that, you will decide whether this result is significant or not. Difference is significant or not. Okay, let me show you. I am referring those two students. Their calculation. Okay. What was I explaining? I was explaining alpha. What is the meaning of alpha? Alpha means confidence level. Significant level will be written in this manner. SL. SL stands for what? Significant level, and the other one is confidence level. Significant level is denoted by the letter alpha. In the graph you must have seen that for one-tailed or two-tailed test, the use of alpha. You must have seen alpha is being used over there. This is alpha, there is alpha, this is alpha by 2 for both-sided test. If significant level is alpha, confidence level will be 1 minus alpha. Means if you are confident, say 95%, confidence level 95%, then significant level 5% you are not confident. If it is 98%, 2% it is not. %4% you are not. If it is 95%, 5% cases you are not. Okay? So what I was going to tell you by copying this diagram, with this diagram, with this calculation, I wanted to tell you these two students, Devans, their name is Devans and maybe someone of you, hypothetically, it may not be taken school student name, maybe like this. Devans has got 49 as mean in his statistic. Bonalika got 68. And Mr. Sarkar, his average in applied maths, among applied maths students of class 12 is 74. Then whose data will be more reliable over there in terms of sample, that we are going to discuss over there. For that we need confidence level and significant level. Significant level means it is risky. Significant level means it is shaded region over there. Confidence level means this white portion. If your calculation falls over there, this I told you earlier also, then you are confident that your data, your statistical analysis is true and is going to be accepted. But that we have to do with the help of what? That we have to do with the help of this table. Isn't it? This table. And some of these two is what sometimes confidence level we take as beta. Some of these two is always what? Alpha plus beta. This is always equal to 1. Alpha plus beta is always equal to 1. Okay? So sum of these two levels always 1. So again I revise what you need to do. Sampling you have done. Now in your calculation there will be alpha and there will be nu. Nu stands for what? The degrees of freedom. There is n minus 1 for one sample and this is n1 plus n2 minus 2 for two samples. So by knowing alpha and nu, now statistical analysis you can do. Once you understand, then it will not be very difficult for you to score the marks over there. So now let us see this example. Problem number 1 I have taken into consideration. This I have taken from inside the study material. You just open your book, you will get the idea. They are asking to calculate the critical t value. I told you critical t value is important, it is required. From where? That critical t value you will find in this curve, in two-tailed or one-tailed test curve. So for this one, for alpha, this is alpha, not A. For alpha equal to 0.1, degree of freedom 22, find the t value. And for this also. This you are not going to do with the help of this formula. X bar minus mu. No, not by this formula. This you are going to study from table. Then tabulated value and this calculated value will be compared. Okay, coming to that point. First, you know this alpha 0.01 and degrees of freedom 2, how to calculate t value from the table, critical t value. Just see the table. This is for left tail test. This one can be used for left tail or right tail test. Because left tail test, if this one is alpha, minus alpha, this one plus alpha. So this front row, I mean upper row, will give you the value of t when it is one-sided or two-sided, the first row. So alpha 0.01 is there. Can you see alpha 0.01? If you can't follow this board, open the book. 0.01 here. Alpha 0.01 here. And degrees of freedom 22 where? 22 here. So from 22 draw a horizontal line. Just do a horizontal line from 22. And then from 0.01 you draw a vertical line. Okay? Then see how much you are getting. Don't make so big. Yeah. And from here, this thing. So where they are meeting? At 2.518. So for number 1, I mean for the first part, t value is 2.518. Got the idea? This we have to find. Let me tell you in one case where two-tailed test is involved, how to get the t value over there. When alpha 0.10, 0.10 where you can see that. And degrees of freedom 18 also you can see. Just remove this part. 18 also you can see. Yeah, and here this thing. So what it is going to be? It's in the first case, I have told you for left tail t-test. Just let me explain that. I did not explain what will be the position in this curve. In your calculation, you will see that if you do it by that statistic, you will find that it is coming negative. So here also left tail t-test I told, so it will be on the left side. 0, minus 1, minus 2, and say this thing is minus 2.518. So it will represent this part, left side of that. Okay, minus 2.518 will represent this shaded region. If you have that calculated t value below minus 2.518, you have to reject. But here We don't know what going to be. We'll take one exact example, then we'll do. So minus 2.518 will lie over there. Previous one, you remember what data I got? That is 1.734, and it is true for two-tail test. So how do you do it? How do you do it? This t value is both positive and negative. This we found minus 1.734. Why both? Because it is two-tail test. That's why both. This part okay, done. So you have to do it there. You have to set the region there. Now you may get that t value positive. Acha, for negative let me discuss. So this region going to be rejected region. We are writing RR. And this region accepted region means if t value, that theoretical t value falls over there, we will accept it. Okay, this is accepted region. Here, if it is below minus 1.734 or on right side of 1.734, then that will be rejected region, RR. RR here, but this will be accepted region. Anything lying in between these two, which you get by using this statistic, S by root n will be accepted over there. Before we start the next problem, let me explain another one. What is that? Suppose that 95% confidence interval states that population mean is greater than 100, less than 300. How do you interpret this result? Can you say? Yes? What do you say about this? This means 95% chance is there so that population mean will lie between 100 and 300. There is 95% chance that x bar will be greater than 100, less than 300. Clear? Understood? I hope you have understood. Now go for next problem. One sample t-test. I have taken an example this way. This is on what? One sample t-test. School claims that, just this is the sum, average score of their student in national test 75, sample of 10 selected, scores are as follows. Test the schools claim at 0.05 significant level. When a school claims something, then they do it in general. But suspicious person also there, like one parent. He collected data of, say, these 10 students individually by asking them. Then what school authority has told, it is correct or wrong, that will decide at 0.05 significant level. Okay? So let us go step by step. What to do there? You need t equal to x bar minus mu by x bar is what? this mean. Keep your calculator ready. I am also doing it with my left hand. 70, 78, 74, 68, 76, 80, 72, 69, 'this divided by 10. See what I have got here. This divided by 10. My calculation shows that it is 73.7. Okay. What is n here? N is 10. And what is alpha here? 0.05. So before you do further calculation, what you are going to assume? You are going to assume the null hypothesis. What is that? H0, we assume that mu is equal to x bar. What are we have written? Mu not equal to x bar means not 75. Here assumed alternative is not equal to. Not equal to means you need to do for two-tailed t-test. Coming back to that point. Now let us calculate the value of t first. Before that, we need to calculate S. S stands for what? That is sample standard deviation. This is under root 73.7 minus 70. Calculate this. 78 minus 73.7. That is 4.3. (68 minus 73.7). That is or opposite, that 5.7 square. This way, you need to continue up to this. That divided by 10. Now calculate these differences in your calculator, their squares. I am also doing it here. So this calculation giving me S is equal to 4.197. You just calculate. Very boring without calculator. It is very difficult for me. 4 point, I got that by using calculator. In exam, if it comes, you have to calculate. Hope that they will give you all integers. Okay, now find t. S we got t equal to x bar minus mu. X bar you got mu. The authority has told it will be 75. That divided by root n, 10. So again I have to calculate this. I am not here to show you the calculation. Please do it yourself. I am doing it very fast here. Oh, yes, done. This is coming. Minus 0.987. Okay. So you got calculated value of t calculated minus 0.987. Okay. Now with degrees of freedom I wrote wrong here. Please, you don't do the mistake. For n equal to 9, and alpha equal to 0.05, just find the value of what? X bar minus mu this we have calculated. S by root n, we found its value. X bar minus mu by S by minus 0.987. Now we are going to do it from the table. Just take the table here. We will take the table here. Oh my God, this is not table I have to take. Yeah, this is the table where you will get tabular value of t. How do you get? In 9 and alpha 0.05. In 9, n is 9 and alpha 0.05. .05 lies here, but this you have to do with the help of two-tailed curve, because you have taken the hypothesis as mu not equal to x bar. Okay? So two-tailed curve alpha 0.05. This is going to be what? 2 point, check. This one, 2.262. Okay, with 9 degrees of freedom and 5% level of significance, 2.262. Now draw the normal distribution curve. I mean that curve. So what have we got there? 2.262. So you have to take minus 2.262 and 2.262 both. Taken approx. Now what t value you get calculated? Minus 0.987. Somewhere like this. This is origin. This is in blank. this is called accepted region and this is rejected region. So since the tabulated value doesn't include, tabulated value will give you what? That critical region. That doesn't include minus 0.987. So what? We'll assume that there is no sufficient reason to cancel, to reject the null hypothesis. It's true. Got the point? Hope you have understood. Now, let us see a problem which is asked in your board paper, CBSE paper. Because I have taken enough time today, I will not take much time. Okay, all the questions I will not be discussing, which I have shared with you. Let us do this one. The manufacturer, just go through the sum. Electric, this came in last year's paper, makes bulbs and claims that these bulbs have mean life this. Life in month of random sample of 6 such bulbs are given to be this. Test the validity of manufacturer's claim at 1% level of significance. Okay? You have to answer the same manner. I'll keep the table ready here. Yeah, this is the table. But this mark has become permanent. Okay, we'll manage. So, what is alpha over there? And this is given 5. What does it mean? 5 means that 5% level of significance. That value they have given. In exam, hope that they will provide all the data. N equal to 5. So you find x bar first. See, both question they have not taken very large data. That divide by 5. Just add and divide. Oh no, sorry, one more is there, 18. So it will be divided by 6. Then it was 120, now plus 18, 138 by 6. 21, x bar 21. Okay? Mean is what? They have claimed it is 25. Mean 25. Then S we have to find. S is x bar minus x1 whole square. (24 minus 21 square), 5 square, 9 square, 1 square, 1 square. That divided by how much? Oh, 18 also there, that is that divided by 5. Let me calculate this. 1 square, 3 square, 5 square, 1 square. One mistake I got there, sorry, extremely sorry. This mean I have calculated wrong. This is 23. Okay? So it will be 1 square, 3 square, 7 square, 5 square. That divided by 6. So add and calculate. It's coming 102. So with calculator only we will find 102 by 6 square. 4.12. Sorry, 4.12. Okay, this has become 4.12. Now what to do? You find t equal to by root 6, we take it up. Now again calculate. This is coming 1020. Okay? T value going to be minus 0.1020. Okay, now what will be your conclusion? If you go for the null hypothesis, we have considered? No, we have not considered. Mu 0 equal to mu equal to x bar, which we have assumed. Let mu equal to x bar. Assume that this is what? H0. Mu not equal to x bar, this is HA. T value we got oh my god, sorry. So we need to tell test. The value of t we have calculated from the given data minus 0.1020. Now for alpha 0.01 and n equal to 5, let us find the value. For two tail test, 0.01 and 5 is coming 4.032. See this one. 4.032. .032 means here and is here. We need to test here. Hope you remember the concept. So that minus so it is not in the critical region. So mu equal to x bar, that can be accepted. That is 25, that we can take. Mean value 25, now we can accept by statistical analysis. Hope you have understood. Practice sums. Send you doubt if any. See you again later. Thank you.